All right. We are going to start chapter 3. And I realize that we've done, we just got out of chapter 11. But I like to do all of the math stuff together. And so we are going to. We're going to do this today. So let me make sure I'm recording. Good. All right. All right, so chapter 3 is all about how to make appropriate measurements. And one of those ways that we make appropriate measurements is using the metric system. In this classroom, we do not use the customary system of measurement that we're used to. We don't measure things in pounds or inches or feet. We use grams and centimeters and meters to make our measurements. So this is chapter 3, section 2. All right, our objectives for the first part. Now I have this kind of broken into small sections so that we can get one concept and then before we move on to the next. You do not have to write our objectives down, but the first part here is the US versus SI. SI is just another way of saying metric system. It's the System des Internationales or the International System of Units, metric units, all that kind of means the same thing. What I want you to be able to do is compare our customary units that we're used to using, the feet and the pounds and the inches, and compare those to metric units. And then we want to talk about what would be some advantages to using the metric system specifically in a science classroom. So let's begin with what is the customary system? The customary system of measurement is only used in the United States. It used to be used on a global level, but the rest of the world has, kind of gotten away from it. The United States, along with, I think, the Myanmar, it's like a really tiny country. They still use the customary system, but everyone else, they're on to metrics. The thing about the metric system that I have never really been able to make work in my brain is it's all about fractions. You add half a cup, it's 2 3/4 inches. That's how we measure things. And in our generally, and I'm not saying everyone, but generally we tend to not be great at fractions. Like if I asked you to multiply and divide and add things with fractions, most of y'all's heads would be like, yeah. We're not so great at fractions. And considering our entire system of measurement is based on those fractions, that kind of, that's always been very ironic for me, I guess. Another thing about the customary system, so not only do we have to be able to use and utilize fractions, we also have to memorize multiple relationships. How many feet or how many inches are in a foot? Anybody? All right, so 12 inches are in a foot. How many feet are in a mile? Does anybody know that one? Anybody? If we're not on task, I'm angry about it. Just going to throw that out. What? No, not in a mile. How many feet are in a mile? What? 5,200 and something feet are in a mile. My point is that I could go through and I could give you all types of things. How many cups are in a gallon?
16.
I don't know. I have a magnet on my refrigerator.
5,280.
That's what I said. 5,280 feet are in 1 mile. My point is that in order to convert, so say you know how many, like we do it for track. How many feet are, in this, and then we need to have that converted to inches. You have to know the qualities to be able to do that. Those kinds of things have to happen often, especially in cooking. Like I said, I have a magnet I stick on my refrigerator. It's on the front of it, and it has all the equations. It tells me how many cups and pints and tablespoons and things like that are all equal to each other. I don't take the brain space to memorize all of it because I got my magnet there. But for us to be able to readily use this, we have to know all of these different equalities. So the the U.S. system uses customary measurements. It's used in the United States and Myanmar, which is a very small country in Asia. It's mostly based on fractions, and you have to know lots and lots of equalities in order to convert between those. The metric system, or the SI system, on the other hand, the International System of Units, metric system, is set up a different way. The metric system is based all on multiples of 10. So I don't have to know that 1 foot is equal to 12 inches and there are 16 ounces in a pound and 5,280 feet are in a mile. All of it's just based on multiples of 10. So 10 times 10 is this, or 10 times 10 times 10 is this. And those are usually things that we can do pretty simply in our head by just adding zeros. This makes our conversions very simple and easily remembered. Another advantage to the metric system is the fact that it's used worldwide. And there's a couple of ways that that's advantageous. If you were selling a product, where you're required to put certain things on the packaging. So in the United States, maybe it's measured 26 ounces, but in the rest of the world, they don't know ounces because the entire rest of the world is using the metric system. So we'd have to choose a metric unit to do that. So it's consistent all the way across. If you go in a grocery store in China or in Germany or in Norway, the packaging will all be similar because it's all in metric. Another way is when we do any kind of trade between countries, this makes life a little easier that it's all consistent. In terms of tourism, I think we kind of, in the United States, we're used to this giant country. And we don't realize that if you were to look at Europe and how it's set up, I have a family member who lives in Germany and okay, so for this summer vacation, I might take the kids and drive to Florida, right? And that will be yay, y'all went to Florida. Well, and my cousin that lives in Germany, she might take her kids and drive to Italy in about the same distance. It's just, if you kind of think of Europe like the United States, but every state was its own country. So when you go between those country lines, when you have tourism, when we're going across those borders, it's important to have things be consistent. So we want our distances measured in kilometers, and that's the same everywhere. It's one of the reasons they went to the euro, so that the currency didn't have to be exchanged every time you crossed the country's borders. Could you imagine if you drove to Missouri and you had to have, it was all different set of measurements and they had different money in Missouri? It'd be crazy, right? It'd be hard to do and it would be difficult and inconvenient. So that's one of the reasons we use this. In terms of science, we only use the metric system when doing lab values because it is consistent worldwide. We want to be able to communicate our lab results with every single person or laboratory on the planet, regardless of where they are. And if you were to put your stuff in the metric system, if your measurements were made in grams and milliliters and so forth, a student in Germany, a student in China, a student in Russia could all read yours and they would know what you were talking about. So it's consistent across the board. All right, so you don't have to write this down. Let's just see. Advantages of the metric system. What is one of the biggest advantages? What do you think? That's right. You don't have to worry about that. And not even just the money. It's just consistent. That's true. Well, you just have to do a currency exchange. But my point is it's the metric system's consistent. Everyone understands it if we all use the same system. And then it says for the difference between customary and metric. What do we measure things in customary system? What do we have to have a good understanding of? What is it? I don't know what you're saying. Relationships. That's good. What about fractions? Do you need to know how to do fractions? Yes. Do you need fractions in the metric system? No. All right. Well, we are going to pause our note taking. We're not done. We're going to come back to this, but we are going to watch a brain pop on customary versus metric. So I'm going to pause this. Okay, we are going to move on to the next part of our note section here. So far we have talked about the customary system, which we use in the United States, and the metric system, which is what we're going to be using in this classroom. So it is important for us to understand and be able to use the metric system. This should absolutely 100% be a review for you. My child is 8 years old and they are measuring things in centimeters in second grade. This is not the first time you have heard these words. So even so, I'm going to teach it just like it is. What I need you to be able to do at the end of this section is I want you to be able to understand the difference between a quantity and a unit and also be able to tell how they're related. I want you to be able to match those quantities with the correct unit. I want you to understand the mathematical values of the prefixes and how using the prefix will change the value of our base unit. So let's get started. There are some common quantities that we're going to measure over and over again, especially in a chemistry setting. A quantity is referring to what is being measured. So a unit is what you measure it with. The quantity is what you're measuring. For example, let's just look at these right here. If I say to you 31 seconds, what am I talking about? Time. Braden Kimball, you got that? I feel like you ain't with me, man. I don't know why. So I say seconds, you say time. What about centimeters then? If I say 15 centimeters, what could I possibly be measuring? Length or height or width? Some can even say distance. Centimeters. What if I say 9.85 grams? What am I measuring? It's not exactly weight. The word we're looking for is mass, and they're related to each other. Mass is the amount of matter that something contains. Weight has to do with the gravitational force. So my amount of matter would stay the same, but if I went to the moon, I would weigh a lot less because the gravitational pull is not the same. So what I'm saying is a quantity is what is being measured. The unit is what you measure it with. There are some base units that we use to measure some of the various quantities. And there are 5 of them that we use frequently in a chemistry setting. There are more base units than this, but these are the ones we're going to focus on. The first is the meter. A meter is a base unit that we can use for height or distance or width or length. The gram, which is what we measure matter with. We measure mass of samples and objects and so forth we put it on our scale and we get our measurement in grams. What about Kelvin? Does anybody remember where Kelvin is? What's Kelvin measure? Anybody? Degrees. Temperature is really what we're trying to go to. Kelvin is based on a scale, and we're going to do some temperature readings when we do gas laws, but Kelvin is a scale, like Fahrenheit is a scale of temperature, Celsius is a scale of temperature. Kelvin is also a scale for temperature. It measures particle movement, so there's no negative numbers in the Kelvin scale, which is why we embrace it in the metric system. Seconds, which of course measure time. And then last, but definitely not least, the mole. And sometime next week, you will know all about the mole. All right, so if we have our base units, our base units measure quantities. So whatever we're trying to measure, we pick the appropriate unit. And then if we have a base unit, we can then take prefixes and attach to these base units to help us have a more or a better measurement sequence. So our prefixes, every prefix has its own numerical value, and they're all based on multiples of 10. So if the base unit is 1, we're either going to multiply or divide by 10. In order to change the value of the base unit to make it more reasonable for us to use, we'll add a prefix to it. So we have prefixes being attached to base units, and that's going to change their value. And all of these are going to be based on multiples of 10. You think they're okay over there?
Yeah.
Ooh. I don't know if it's like weeping or laughing.
Sounds like both.
No. Okay. Are we good on this slide? Can I move you up? All right. The prefixes, the values that, and you have to know that kilo means this many. Mega means 1 million. Kilo means 1,000. Hecta means 100. Deca means 10. Deci means 1/10. Centi means 1/100th. Milli means 1/1000th. And micro means 1 millionth. All of these are based on multiples of 10. Deca is 10. Well, 10 times 10 is 100, which is hecta. Okay, they're going to have to stop. I don't know. The teacher was standing right beside them, so but they're quiet now. All right, so we have our prefixes. Everything is multiples of 10, and that's why the metric system is easy to remember. And if we want to change the value, All we have to do is take and put a prefix that works with it with our base unit. So if I wanted to write the symbol for 1,000 meters, well, what is the prefix that means 1,000?
Kilo.
Kilo. And then I attach that to the base unit meter. Kilometer. Now I want you to think about it. This is a meter stick right here, okay? On the meter stick, there are centimeters, and this is 1 meter. A centimeter is about this long, about my fingertip. If I needed to measure the height of my yes, ma'am. I mean, it's been up there forever. Can you get it from someone else? Because I'm not going back. I mean, I walked to a whole other room and came back. I mean, anyway, it's on video. I'll post it in the classroom. You can go back and look it up there. So here we have, if I wanted to measure this, centimeter would be the way I'd want to use this because I can measure this here. I put it at the ends. This is approximately 12 centimeters tall. Would you want to measure the distance from here to Taco Bell in centimeters?
No.
Would you even want to measure it in meters?
No.
No. It would be much more appropriate, though, to measure it in kilometers, which means 1,000 of these. 1,000 meters.
What about here to Pontiac?
To where?
Pontiac.
I don't know what Pontiac is.
Pontiac, Ohio.
Definitely kilometers. I would definitely use kilometers. All right. The same if I wanted to measure 1/100th of a gram. What means 100th? What is 1/100th? Centi. And so all I do is I take the value, centi. I know that that is 1/100th, and I attach it to the base unit. Easy peasy. We use these prefixes in these base units in order to make our measurements more reasonable. Like you would not want to measure that expo marker in kilometers, but just like you wouldn't want to measure the distance from here to Taco Bell or whatever, any distance, you wouldn't want to measure that in centimeters. You have to choose the most appropriate value. Questions? Okay. The next thing we are going to do then is we are going to convert between metric units. And I'm actually going to write this down. You can probably do it in your Chromebook, but this is a skill I expect you to have by tomorrow. If you do not understand it today, after years and years and years of having the metric system, we need to be asking some good questions, and we need to, because tomorrow we're going to have a quiz. And on that quiz, we are going to convert between metric units. So I'm going to show it to you. We're going to talk about it, and we're going to hopefully all be masters at converting between metric units. All right. It's just easier for me to write this down so I can show you as I do it. Converting between metric units. We are going to use something called the decimal slide method. In order to use the decimal slide method, you're probably going to remember hearing the term kangaroos hop down little grassy mountains drinking chocolate milk. Does that ring any bells for anybody? Okay. If it doesn't, we're going to explain what that means. In the decimal slide method, we are going to use kind of like an acronym where we're going to use a saying to help us remember the order of our prefixes. And what we have said in the past, and I've heard other ones as well, but this is the one that seems to be the most popular. Kangaroos. So there's kangaroo, the kangaroos, K. Hop. Down. And then in middle school, we said little grassy mountains. And you can keep that there, but what I would prefer you do is just leave this as a blank spot. Little grassy mountains refers to liters, grams, and meters, which are all base units. But we can put any base unit in the middle there. So kangaroos hop down something, leave it blank, and they are drinking chocolate milk. So this is kilo, hecta, deca, deci, centi, milli. Kangaroos hop down, leave it blank, have a pause, remember it however, drinking chocolate milk. Remember that all of our stuff, and again, I'm going to show you this, but we're going to, if my base unit is worth 1, if everything is based on multiples of 10, 1 times 10 is how much? What's 1 times 10? Oh, come on now. 1 times 10 is 10. So deca is worth 10. What's 10 times 10? 100. So hecta is worth 100. What's 100 times 10? 1,000. So see how we're getting our values there? We're going to divide by 10. 1/10, 1 100, 1 1,000. It all works the same way. So this is our metric system. These are our prefixes. Kangaroos hop down something, drinking chocolate milk. In order to convert, we are going to follow this little rule. Start on the right. End on the right. For some reason over the years, I've had a lot of success with this. If you want to be right, oh, I don't know why I wrote year. If you want to be right, start on the right, end on the right. And we're going to talk about what that means. All right, let's say I have been given 5,284 grams of something. And I want to know how many kilograms this is. All right, so we're going to use our kangaroos hop down mountains drinking chocolate milk. So I am going to start at where my base unit would be. Grams is a base unit. So I'm going to start right here at grams. So I'm going to make a dot right there beside gram because gram is the base unit. Gram would be in the middle. And I'm going to move my decimal. I'm going to move this dot until I'm on the right side of what I'm trying to get, which is kilograms. So I'm going to stop it right here. So I'm going to go 1, 2, 3 places to the left. Whatever you do in the saying up here, the letter part, you have to do down here at the bottom. So my decimal is understood to be right here. So now I'm going to move it 3 places to the left. 1, 2, 3. And my answer, 5.284 kilograms. That's it. All you have to do is move the decimal. Wait. To the left, because to go from grams to kilograms, I moved to the left. And I did it in 3 spaces. All right, let's do another one. And I'm just going to write another so I don't have to keep going back up. Let's say we have 6,321.0 millimeters, and I want to know how many meters that is. All right, so which of these is millimeters? Where am I going to start? Right here at the M. So there's my millimeter, and my meter would be what? Where would my meter be? In the blank spot. Meters, grams, those are base units. So I'm going to try to go from here to there. So I'm going to go 1, 2, 3 places to the left. I'm going to do the same thing in my number. 1, 2, 3 places to the left. And I get 6.321, and I can leave that 0 there, meters. Questions? Okay, let's do another one. Let's say I have 5.75 kiloliters of a substance, and I want to know how many liters it is. All right, so I'm going to start with my kiloliters. I have the K, so I'm going to start at K. Here's my dot. And I'm trying to go to liters, which would be a base unit. So there's my second spot. 1, 2, 3 places. In which direction did I move? Right. 1, 2, 3 places. So my answer, 5750. I'm going to be honest. This is one of those things that's very obvious to me. And so it's hard for me kind of sometimes to break it down any simpler. So if I need to, I'll do my best. I may have to rely on some help from our students too, because I want everyone to get it. But tomorrow on our quiz, I'm anticipating 50% of you to fail. I don't know why. I've never understood it. But about 50% of you will make a 0. Because you're going to sit here and be like, oh yeah, I know how to do that. But you don't know how to do that. So I need you to ask questions. If you are not understanding how I got that answer, we need to be able to explore that. We need to be able to talk about it. We need to be able to practice it. All right, you try this one. Well, actually, I'm going to give you 3 to try. You try these 3 right here. And if you can get all the right answers and we're good, you can just do this on your notes. Then we'll talk about questions. Chad. Yes, that'll be fine. I have no problem with that. All right, so let's say I have all right, the first one, 125 centimeters is equal to how many meters? All right, give it a shot. See what you got. All right, I put my answers on the board, so whenever you're finished, you can check your work against mine. If you got them right, yay. If you didn't, we need to figure out what we can do to help you get them right. because it makes my blood pressure high when people miss these. It just seems pretty simple to me. And that's why I sometimes I need to make sure I'm slowing down and I'm giving you what you need. Just because it's simple to me doesn't mean it is to everyone. All right. If that had been a quiz, would you have gotten them all correct? I hear Some of you are no response at all. If you missed one, do you maybe see what you did? Did you go in the wrong direction? Because sometimes that happens. You got to make sure you're going right or left. Just be conscientious about it. Be careful. The other thing, and I put this one here on purpose, these two I like to add in because even though I moved my decimal 3 places to the right, that empty jump right there can't just be left. I have to fill that with a 0. And the same thing in the other direction. 1, 2, 3, 4, 5, 6 places to the left. So those empty jumps, they had to be filled with zeros. Questions about converting with metric units? Yes. Yep. I'm going to do some practice ones too, but let's see. All right, give these two a shot. See if you get them right. Remember, kangaroos hop down something, drinking chocolate milk. All right, my work's on the board. You can check yours against mine, and then let's ask questions. Yes. What? I didn't hear that.
Why didn't you add the 8 on the first one?
Oh, I'm sorry. I just left it off. I wasn't thinking. My bad. I just missed it. You're right. Good call. Good catch. Thank you. All right, other questions, because that was a good one. That was my mistake. I've got to start wearing glasses and pretending I'm not blind. I keep my magnifying glass up here. Oh, so nice to be able to see. Wish my eyes worked like that for real now. Anybody else have questions? So I'm going to give you a 5-question quiz tomorrow worth 10 points. And we're all going to make a 10 out of 10, right? Okay. When you don't, I'm going to be like, okay, tell me why. Tell me what's going on. Tell me why you didn't do this. What's the saying that you need to know? What about kangaroos? The kangaroos hop down, and I don't care what you put in the middle there. Drinking chocolate milk. All you need to know is kangaroos hop down. Something's in the middle. Drinking chocolate milk. Write that down. If you want to be right, put your decimal on the right side of the letter that you have and move it to the right side of the letter that you want, and you'll be right. Any questions? Okay. Well, we're going to do a quiz then. So